What is up YouTube? Welcome back to another episode on Code with Annie. And in this episode, I'm going to talk about some of the data structures that we commonly use. And also I'll give you an intro about how you can create your own custom data structures. And this is a common problem that is asked to people. For example, creating your own array list or creating your own map data structure, right? So let me show you how you can do that. And this is highly conceptually driven video. So please focus on this video to understand that. So let's get started with this one. Now, the different data structures that you mostly encounter with the problems that you are asked is basically string, list, map, stack and queue, mostly priority queue. Then you have trees and graphs, then trie data structure. Okay, these are some of the data structures that came to my mind. If you have encountered other data structures as well, you can hit me up in the comment section, let me know, and I'll try to see if I can explain more on those as well. But for now, these are the data structures that you mostly encounter. And let's say someone asks you to create a custom list of your own, right? How do you create that, or a custom map? Okay, for that, what we usually do is we create a class and we usually call it as node. Okay, now this is how a custom node class looks like. I did already type this out. I also created a custom list, but I'm going to talk about it in 2 videos, not in the single video, because that's going to be a bigger topic and it is highly conceptually driven. So let me show you how you have created a particular node class. This is going to be the class which represents the data that is going to be present in our list. Okay, so you have to create a class called node, and I've given type T here because I'm using generics. This node class can accept any kind of data type. It can be integer, string, boolean, double, float, whatever it is that you want to give it, or any custom object as well. So I have created it using generics, and all this class is having is the data itself and 2 pointers here. One pointer that is going to point to the next element, and one pointer that is going to point to the previous element. Okay, so this is a doubly linked list implementation, meaning for every element in the list, okay, if this is the element, this element has a pointer to the next element and also the pointer to the previous element. Okay, and there is a constructor here which is going to accept the data and just assign it to this particular data, this dot data equal to data. Okay, so instead of keeping these public, you can also keep it as private, and then you can have a getter method to get the data next and previous. For the sake of this video, I'm just doing it like this, but we can alter it according to our convenience. What I'm intending to say is the data that you want to represent in your list or map or whatever it is can be represented with something like this. Okay, we'll always call it as a node, and if it is a map, it's going to be slightly different. Map will have key and value, right? So you'll have not just one data, you'll have a comma separated data, right? You have key, t space key, and t space value, and you can assign key and values to variables here, and then you can manipulate based on that. So effectively, everything that you see as a predefined data structure provided by Java can be recreated by yourself using Java itself. For example, I'm using the Java class here, right, to recreate it. So how this will pan out is, let me write it in the comments here. So let's say you create a node, right? So it will look like node space node is equal to new node of 10, let's say. Okay, the moment I give 10, automatically type T will become integer, and this is going to be an integer representation. So the data is an integer data. Then I can say node space node 1, or let's say this is called as the head node or the starting node. Then you have node 1, which is equal to new node of 20. Okay, then I have node space node 2 is equal to new node of 30. Okay, likewise I can keep creating new node elements, and it will each hold a particular data. Now I will also have to link up these nodes, right? Because head, node 1, node 2, everything is having initially the values as null. Okay, so what I'll have to do is head dot next is equal to node 1. Likewise, node 1 dot previous is equal to head. So understanding the linkage, and what I'm trying to say is the first element is going to point to the next element is going to get linked to the next element, and the next element's previous element is going to be the first element. Likewise, node 2 dot next. Okay, you have to understand the pointer differences between next and previous, right? Next node 1 dot next is going to be node 2. Likewise, node 2 dot previous is going to be node 1. Okay, now this has formed a chain from head to node 1 and node 1 to node 2. Now head dot previous is going to be null because there is nothing prior to the head, that is the starting point. Likewise, node 2 dot next is going to be null because there is nothing after node 2. We have only 3 nodes here. So this linkage can be done with a custom list implementation using an add method. Okay, we can simply say list.add, and if you pass a node to it, it will create this linkage and return back. Okay, so this is how you can connect the elements to form a doubly linked list. Okay, doubly linked list because there is a connection, there's a by connection, right, from node 1 to node 2 and node 2 to node 1, right? So this is the custom class implementation. You can take a look at this slowly, and you can try to write your own custom class implementation for, let's say, a map as well, using this as a reference. And trees also can be represented like this. Trees have something called left and right nodes, and instead of next and previous, it will be left and right, and we will point the elements appropriately from the starting root. Now the head is going to be the root for a tree. I'll talk about tree data structures in detail, but for now you can leverage this node class and try to write your own node class for a hash map and see how you can work that out. In the next video, I'm going to show you how you can create a custom list implementation. I have it here created, but I'm going to walk you through that slowly because this is a important concept. And if I type it, it might be confusing for you. So I've already typed it out, and I'll explain it with an example or dry run it for you guys. Okay, so that's it for this particular video. If you liked it, do hit the like button, subscribe to CodeWithAni if you haven't already. DS and algo is a very critical topic, and it is taking a lot of effort from my side to create videos for you because I have to be cautious on what kind of content I put out on this particular playlist. So do support the channel, and I'll see you guys in the next one. Bye bye.